Earth's magnetic field is one of the planet's most critical protective shields, extending thousands of miles into space. It's generated by the movement of molten iron and nickel within Earth's outer core, creating a dynamo effect. This invisible force field protects the planet from harmful solar radiation and plays a crucial role in maintaining life as we know it. But what would happen if Earth's magnetic field disappeared tomorrow? How would it impact life, technology, and the very stability of our planet? Today, we'll explore the unsettling consequences of losing Earth's magnetic field and what it means for our future. The first and most immediate consequence would be an increase in solar and cosmic radiation reaching Earth's surface. The magnetic field acts as a shield, deflecting charged particles from the sun, known as solar wind. Without it, these particles would bombard the planet, exposing living organisms to dangerous levels of radiation. High radiation exposure can damage DNA, increasing the risk of cancer and other genetic mutations in humans and animals. Over time, this could lead to severe health crises, particularly for populations living at higher altitudes or near the poles. Earth's atmosphere would also face significant threats without the magnetic field to protect it. The solar wind would gradually strip away the atmosphere, much like what happened on Mars billions of years ago. Without an atmosphere, Earth would lose its ability to retain heat, leading to drastic temperature fluctuations. The planet would become a hostile environment, with scorching days and freezing nights, making survival nearly impossible. Over centuries, Earth could transform into a barren, lifeless world, much like our neighboring planets. Another immediate impact would be the failure of modern technology, particularly satellite systems and global communication networks. The magnetic field protects satellites and spacecraft from charged particles that can cause electrical malfunctions. Without it, satellites would be bombarded by radiation, leading to disruptions in GPS, internet, and telecommunications services. Power grids on Earth would also be vulnerable, as solar storms could induce massive electrical surges, causing widespread blackouts. The loss of the magnetic field would plunge humanity into a technological dark age, affecting every aspect of modern life. Navigation systems, which rely on the magnetic field, would become obsolete almost overnight. For centuries, humans and animals have used the magnetic field for orientation, with compasses pointing reliably to magnetic north. Without the field, traditional navigation tools would fail, leaving us to rely entirely on GPS systems that may no longer function. Migratory animals, such as birds, whales, and sea turtles, would lose their sense of direction, causing widespread ecological disruptions. These species rely on the magnetic field to navigate vast distances, and its disappearance would throw their life cycles into chaos. The disappearance of the magnetic field would also have profound effects on Earth's geology. The field helps regulate the behavior of charged particles within the planet's interior, stabilizing tectonic activity. Without it, the planet's core dynamics could shift, potentially increasing the frequency and intensity of earthquakes and volcanic eruptions. Earth's protective magnetic bubble, known as the magnetosphere, also shields the upper atmosphere from solar winds. Its loss could lead to changes in atmospheric composition, disrupting weather patterns and climate systems globally. Auroras, those stunning displays of light at the poles, are created when charged particles interact with the magnetic field. Without the magnetic field, auroras would cease to exist, and the skies would lose one of their most spectacular natural phenomena. Instead, we might witness chaotic, dangerous electrical storms in the atmosphere as solar radiation interacts directly with Earth. The loss of the magnetic field would rob us of beauty while introducing a new era of atmospheric instability. While the disappearance of the magnetic field would be catastrophic, it's worth noting that the field has weakened and reversed many times in Earth's history. Magnetic reversals occur roughly every 200,000 to 300,000 years, during which the field temporarily weakens but doesn't vanish completely. Even during these periods, life has persisted, though some scientists speculate that reversals may have contributed to past extinctions. The difference is that a complete and sudden disappearance, as we're imagining here, would be far more devastating. Earth's ability to sustain life depends heavily on the consistent presence of its magnetic shield. The magnetic field also plays a role in protecting Earth's ozone layer, which shields us from harmful ultraviolet (UV) radiation. Without the field, increased solar radiation could degrade the ozone layer, allowing higher levels of UV radiation to reach the surface. This would lead to a spike in skin cancers, cataracts, and damage to crops and marine ecosystems. UV radiation also affects phytoplankton, the foundation of oceanic food chains, potentially disrupting marine life on a massive scale. The loss of the magnetic field would create a domino effect, impacting life across every ecosystem. In addition to the direct threats, the psychological impact of living without the magnetic field would be immense. The constant exposure to radiation and the collapse of technology would create widespread panic and social unrest. Populations living in high-risk areas would face displacement, leading to mass migrations and global humanitarian crises. Governments and organizations would struggle to adapt to these challenges, as the scale of the disaster would overwhelm resources. The disappearance of the magnetic field would test the resilience of humanity in ways we've never experienced before. Scientists continue to study Earth's magnetic field to understand its behavior and long-term stability. While it's unlikely that the field would disappear entirely in the near future, its weakening over the past few centuries is a cause for concern. The South Atlantic anomaly, a region where the field is particularly weak, has raised questions about the potential for future disruptions. Studying the magnetic field helps us prepare for possible scenarios and develop strategies to protect life and technology. Advances in science and engineering could one day allow us to mitigate the impacts of a weakening or disappearing magnetic field. The magnetic field is a reminder of Earth's delicate balance, where even invisible forces play a critical role in sustaining life. Its loss would highlight the interconnectedness of our planet's systems, from the core to the atmosphere and beyond. Protecting Earth's magnetic field and understanding its dynamics are essential for ensuring the survival of future generations. The more we learn about this invisible force, the better equipped we'll be to safeguard our planet and its inhabitants. Thank you for joining us in exploring the question, what if Earth's magnetic field disappeared tomorrow? This thought experiment reminds us of the vital forces that sustain life on our planet and the need to protect them. Until next time, appreciate the unseen forces that shield us and marvel at the complexities of our extraordinary world.